Welcome to the Optimum CAD solution. I am Pankaj Ratnaparki. Once again will start the discussion on a free online course that is Plastic Product Design and Advance CATIA. Today we are going to cover a tutorial number 9, the plastic cover. So before that we'll just check our online course content. So we already covered the plastic product design introduction, domains in automobile design, plastic product design theory, and here we are at the Advanced CATIA. So those points are already covered during the course and the videos are available on the YouTube. So you can refer our channel. Without wasting the time, let's moving towards our today's task. So this is our today's task, 2D design. With the help of this design, we are going to convert 2D into the 3D. So let's see the different step. With the help of we are going to convert 2D into the 3D. So those are the few steps. And here the final 3D. So let's open the CATIA. We will give the cover as a part name. So here we are in the part design. So let's take a central origin. We'll take axis system with respect to that origin point. We'll hide the all default planes and we'll start the 2D design from sketcher. So this is the rectangle of a 80 by 80. It's a square of 80 by 80. So we'll take a center rectangle command and we'll apply the dimensions as a 80 by 80. So this is the 80 mm. This is also the 80 mm. So these pockets we need to take, but before that we'll take a pad of a 12 mm. So this is the 12 mm thickness. So let's give the 12 mm here. So it's a 12 mm actually. So the first step is get completed. Let's check. So this is the first step. Now this pocket we need to do from, we'll take a dimensions from the drawing. So this is of a 16 and 16 mm from the corners. So we'll go into the sketcher and we'll draw the profile by using the reference of a rectangle circle. So we'll take all the sides as a reference. So they start from the corner. So we'll take a rectangle from that corner having the dimensions of a 16 by 16 and it has a radius of a 8 mm. So here is the 8. So this profile is at 4 corners. So we need to mirror them. So here we'll do the pocket of 6 mm. So here is the 6, 12 minus 6. So here the step 2 gets completed. So now we'll give the chamfer of a 3 by 45 degree. So length into the angle 3 into 45. So here the step 2 is get completed. Now we need to do those pockets. So let's again we'll go into the sketcher and we'll check the dimensions from the drawing. So we'll take the reference of 80 by 80 rectangle. So here is the circle of a 520, 36 and in between that the diameter is of a 30. So we'll draw 3 circles. We are going to use the combine sketch, and whatever the output we required we'll do that by using the output profile. So here is the output feature and output profile. So now this pocket we need to design. So this is parallel. This is of a dimensions 1 point. So this is actually 3 mm. So let's edit it as a 3. So this is also the 3. So this is of a 15 mm. So 7.5. So let's mirror it to complete the profile, and we'll erase the unuseful features. So this is also the 4 pockets. So we need to use the mirror command. So we can do those mirrors into the sketch also, and after pocket you can do the mirrors, do the pocket by using the 3D mirror command also. But for simplifying, we are using the mirror into the sketch. So let's pocket the, before that the profile is not closed, so we will close the profile. So here the sketch is get closed. Now let's do the pocket. So this is the throughout pocket. So it is the throughout. So here pocket is get completed. Let's pad for 6 mm. So here the basic design is get completed. So we have to maintain the internal thickness. So we can use the boolean operations also, but before that we'll do this pocket. So we can use the boolean operations to maintain the thickness, but in the previous video I got a comment that can we use the shell command. So today we are going to do this by using the shell. So here whatever the thickness we required, we have to select that face, and we'll give the default inside thickness dimensions. So let's select all the faces where we have to maintain the thickness. So you can use the boolean operations also, but this is the smaller part. There is no any bigger history, so we are using the shell command also here. So here the you can see that the uniform thickness is get maintained. So thickness is of a, so this is the uniform thickness is of 1 mm, so we can read it rather than 1.5, it's 1 mm. So now this internal pockets and holes which having the dimensions of a 9 mm diameter. The pocket is of a 9 mm, so the circle we have to draw 9 plus 1 plus 1, that is the 11 mm with the reference of this. So this is of a 11 mm, this is of a 9 mm. So rather than using the combined sketch, to simplify we use the separate sketches here. So the 4 pads are there which having the dimensions of a 2 mm offset, it means 10 mm. The 12 minus 2, and it is from that face, so we need to give the minus 6 there. So here we can see the cylindrical pad is get completed. So now again we'll go to the sketch for doing the pockets. We'll take a reference from diameter 11. So let's draw the circle with the reference of that 11 mm. So that pocket is of a 9 mm diameter. So let's give the 9 mm, and the internal diameter is of a 5. So let's take output profile. So let's pocket. So that 9 mm diameter having the 1 mm thickness at the bottom side, so that uniform thickness we have to maintain. So we'll pocket for 9 mm, and second one is throughout pocket. So here, except the ribs, the 3D object is get completed. You can see. So these pockets are done. So now let's move towards the rib design. So those ribs are we need to cover. So it having the dimensions 4 mm, 10 mm and 1.5 mm thickness. So let's draw. So first of all we'll draw the sketch with the reference of previous. So this is 20 mm, thickness is 1.5, and it is offset 5 mm from the center. So for mirror we need to make one axis which having the 45 degree from the center, and we'll use that axis for mirror. So here the basic ribs are get completed. So we'll pad for 4 mm thickness, 4 mm height. So before that we'll separate the bodies. And we'll insert the separate body for rib. So now let's pad the rib for 4 mm height. So here is the 4 mm. So now this inclination we can use the chamfer also, but we will do the pocket here. So by taking the references. So this pocket we need to do. So let's pocket from both two ribs common. So here the two ribs are get completed. Now we'll use the array command. The 4 instances with the help of that circle, and here the ribs are get completed. So we'll give the name to different bodies. So this is the basic body and this is the so after completing we'll add all the bodies into the part body. So this is the rib body, also this is going to be added into the part body. So here the 3D object is get completed. So here is the 3D. So we'll take a section for checking the uniform thickness. So you can see the uniform thickness is get maintained. The thickness was 1 mm. So here you can see during this section. So here our today's video is get completed. Thank you for watching our YouTube channel. We'll try to share more and more technical knowledge related to the plastic product design and advanced CATIA. But before that, you have to subscribe, like and share our videos. And do not forget to hit the bell icon. Thank you guys.